Now we're live from downtown Quebec. In terms of modern examples of where did it just get shut down? No, there we go. Did I go over this last day? Some really interesting experiments. I thought it was fascinating because, of course, I was in biochem. You may not think it's quite as fascinating, but it is. It is fascinating. E. coli, it's a bacterium that lives in your gut. Everybody has it. It's called E. coli. There's a different one for every different species. You'll occasionally hear about it in the news associated with food poisoning. Food poisoning to the extent that they will recall all vegetables that were near the farm that had it, because it's an amount of food poisoning that can kill you, particularly if you're immunocompromised, you are young, you are very old, or in other ways on the edge, as it were. If you already have the flu and you get food poisoning, that combination can set it over. So it can be quite deadly. All it is it lives in another organism's gut. If you eat it, and it was, say, from a cow, it might find your gut particularly pleasant and then reproduce to the point that it overtakes you and then you die from it. But every organism has a version. You have your own version of E. coli inside of you. It's a widely studied organism because it's really easy to grow in the lab. We grow it on petri dishes, and a postdoc started doing an experiment where he would grow it on different types of nutrient medium to see what mutations would pop up. So you'd grow it where there was a certain lack of a nutrient, which ones would survive, or it was in short supply in different harsh environments. And then he would have different strains they would adapt. But E. coli as a bacterium, this is true for lots of bacterium, you can freeze them and then regrow them. Freezing doesn't kill them. The cells are small enough that they don't get the same crystallization and then crushingness that a human would get if you froze a human. So they can be revived after frozen. So he has a sample of every population that has ever existed. While doing that, and he's growing in these different mediums, I just want to make sure I have everybody's eyes, Aiden, because this is amazing. While doing that, I don't have everybody's eyes. While growing, he found a mutant that ate citrate. And you may be thinking, I don't even know what citrate is. It's just a nutrient. But E. coli doesn't eat citrate to the point that it is defined as a bacterium that doesn't eat it. It's in a class. There is no biochemistry metabolic pathway by which it could. It would be the equivalent of a human being born and being able to photosynthesize. It would be like, wow, this shouldn't have happened. It was an amazing event. So because he kept samples, he was able to go back in the previous generation. Oh yeah, it had a mutation for something completely different. And the previous generation had a mutation for something, and there was a path by which it took that it could eventually get to citrate. Did it know it would need those mutations in the future? No. It was just purest accident that it managed to get to the point that it could do something that no other E. coli could do. And he had the entire lineage, so he was able to track it genetically, which was the first time we were able to do that. Bacteria are really fast growing, so we can actually do those experiments. Can't do them well with animals, so we're not going to see that, sprouting wings. But you can see the biochemical pathways, which is really cool. We are at a point, I don't know if you've ever burned plastic for fun. I did. Grew up on a farm, burned plastic all the time. It has a lot of energy in it. Energy that bugs don't eat because it's made out of dead stuff in the ground. We combine it into polymers, and nothing's evolved to eat that. So we're really lucky. We don't have to worry about your desks decomposing. When you go out to your car or the inside of your computer and the circuit board, you're not worried about something digesting it. There's not spores in the middle slowly growing across and plants trying to take root, because plastic, famously, doesn't get eaten by anything, to the point we're actually worried. There's enough microplastics in the world that they say you have enough microplastics in your brain to make a whole teaspoon. Which, I don't know if it's true. I saw it on TikTok, so it must be true. But microplastics are a thing. Nothing eats them, and they just get smaller and smaller and smaller. I'll get questions in a moment. We now have bacteria that can eat nylon. We found some other strains of bacteria that can eat different types of plastics. We are going to enter a world in which something will eventually evolve that can use that energy. It's a free food, and nobody's eating it. The first thing that can take advantage of that is going to explode. Yes?
No, so we haven't done any plastic treatment.
Nylon's a form of plastic. And now we do. Yeah. Can you imagine having to go to your car and like get a treatment when it's sick because it's being invaded by a virus or something? Like, there's going to be things that eat it. And if you have to spray your tires down with antibiotics, we have lost the usefulness of plastic and rubber.
What else if it's sick? Can you like create a bacteria that eats plastic?
We do kind of want that to get rid of things like microplastics, but at the same time, we also, the huge usefulness of plastics is that nothing eats it.
But what,
So,
like wooden desks, they don't, like, I haven't seen like,
you haven't seen one what?
that's like being eaten often.
No, like there's still very few. What I'm saying is that the first ones we've ever seen have just started to arrive. And the first one that evolves that could like eat that chair, how much of a feast is it going to have in this building? A lot. And it's going to go from school to school to school and eating everything, and nothing else will be competing with it. What happens to a population when you have no competition for a food source?
Just keeps growing.
Just keeps growing. So eventually something's going to want to eat that, and we're going to have to deal with that. Right now we're at a time in history we're really lucky. Nothing eats it. It took a long time. The entire planet used to have this problem because you couldn't digest lignin. Lignin is a type of chemical in wood that gives it its stiffness and fibrousness, and nothing had evolved to eat it. And so wood, old wood, would just kind of pile up. Some of it would decompose, but it would just sort of pile up, and you'd have all this dead matter growing. If you have a lot of dead matter in a forest and it's never going away, what is that a risk of?
Forest fires?
Forest fires. And so we had times in which literally the planet burned because a forest fire would start and it would take over a continent because there's that much dry matter there and then nothing could stop it. It would burn everything. We have ash layers that show that this happened
How long
over a
was that?
continent. Pardon?
How long ago was that?
Oh, quite a while ago.
40
And
years?
I want to go look it up and put on a date so I don't really know. But then eventually a fungus figured out how to eat it. And that's the purpose of mushrooms. They digest the things in the forest floor. Nothing else can eat it still. The only thing that can eat it is types of fungus. They all come from that common ancestor. It is a really difficult molecule to break down, and it's the only thing that can break it down for energy. And so wood used to be like plastic. Nothing could eat it. Everything was growing it. And then eventually something figured it out, and then that's its niche. That's what it can eat. We may eventually have something similar for our plastics. We've changed the environment enough that some species have adapted specifically to us. There's the London underground mosquito that demonstrates some characteristics that show that it is adapted not for the marshland in the UK and not for the forests, but specifically for the subway system. It's a constant system that exists, and there's some characteristics that are more useful there than out in the environment. There's some arguments. Some people don't consider it a distinct species, just different types, like you'd have dogs, and some do. There's a great movie, I'll find out the name, maybe I'll post it, in which someone took that idea all the way to a logical conclusion, and they did an entire movie about a species of insect that looks like a homeless person in the London Underground. And then when you get a little too close, just like those leaves you saw that look like leaves, it no longer looks like a homeless person. It looks like an insect that then eats you. It's a horror movie. But the idea that something could gradually become look like something that people would ignore is like a classic hallmark of evolution. Even something as extreme as radiation. The Chernobyl nuclear power plant failure famously left an entire region where humans don't go to live. The amount of radiation is high enough that you will get cancer early and die. Your children will be born with too many mutations. And there are fungi there that have evolved to eat the radiation. They use the radiation for energy for their biochemical processes, so they survive and thrive in radiation. This is also a great area for research, because if we want to clean up after a radiation spill using whatever techniques that fungi is using, that could help absorb the radiation and use it up. but evolution managed to capture the energy in radiation itself. Also, I would like to say, the entire Sharonal area, the animals die early of cancer. And they do have more mutants as babies. And they're doing so well. So well. The forests have come back like you wouldn't believe. The amount of forest creatures are thriving, because it turns out if you take away all the humans and just leave them alone for a period of time, everything just gets better. There's nobody living there, there's nobody taking out. They can put up with a few mutants and their children. They are doing extremely well. To the point that someone proposed, at the density of a normal city, we could fit everybody in the world into Texas. Like everybody, just fit them into Texas. We'd have to pave Texas, like all of it, but like it's Texas, who cares? And then all the other wildlife across the planet would just bound back. We could finally use all the areas that are farmland. Where do we build cities? On good farmland. Let's take away Toronto and give the farmland back. And then some farmers would not live in that area. And then we'd have the whole world as a park. Getting everybody to live in one place, however, would probably be something that would take a bit more work. But I don't know. I think the entire world is just really good at cooperation and feeling really friendly towards each other right now, don't you think?
What about having everyone in one continent?
Pardon?
What about having everyone in one continent?
Yeah, we just put everyone in a continent.
Like Russia.
Where though?
Australia.
Well, okay.
Russia.
Number one, Australia's not real. It's a place in Arizona. They put you on a plane, they fly you in circles for a while, and you land you there, and they say, "Welcome to Australia." You're not really there. You just think you're there. Have you really seen all of Australia? No, they say, "Oh, that's the outback. It's huge," but you don't know. Have you been to Australia? Let's see.
What about like cramming
You should
everyone
be a
into Russia?
geologist.
'Cause it's
Sorry?
big. Russia.
What about Russia?
Not 80% of Russia's a wasteland.
Yeah, it's the same with, well, yeah.
And then Canada.
But that might be a good idea then, because with technology we could live there and let the other places that's good farmland recover. Kick all the other people out. First we have to get Russia to cooperate, and the rest of the world, I'm sure there'll be no problems. We did, just so you know, we eradicated smallpox. You've heard of this before? It famously, you had to get a vaccine. You didn't get the vaccine. It had a really high risk of killing you. If it didn't kill you, it gave you pockmarks all over your body. It caused other problems, heart abnormalities. There's all sorts of side effects, even if you survived. Smallpox was a ravaging, deadly disease. And you could get a vaccine against it, so we vaccinated the entire world, and all of smallpox died. It's going to mutate every year. Eventually, it's going to get to a point where maybe it could evade our vaccinations, and we said, we're having enough of that. We're not doing that anymore. We could do the same with other diseases. It would just take more cooperation. People do mention, like, we have more people now. Yeah, but we also have more funding from those more people. Like, the problem doesn't get harder. It just requires the will of the people involved. We could do more. Currently, there's 233 cases in Texas of measles. The measles, just so you're aware, is not a safe disease. We have not been exposed to the ravages of some of these childhood diseases. We just hear about them from the past because most people have been vaccinated. But measles can leave you alive but sterile. It can damage organs in your body. There is a small chance of death as well. Measles is another terrible disease that we managed to eradicate mostly by vaccines. We didn't eradicate it worldwide. And as soon as people stop vaccinating, it starts popping back. It's really infectious. If you have the flu, like the regular, really infectious flu that we give you the flu shot for, you infect on average about 1.7, 1.8 people. So if you're sick, you'll probably get 2 other people sick, but maybe just 1. If you have measles, you'll get 12 to 13 people sick. That's how fast it spreads in an unvaccinated population. It's hugely infectious. If you know someone with measles, stay the crap away from them.
What about
They're
vaccinating
going to get you sick.
population?
We could vaccinate the whole population in the world against measles. We just haven't. We were that close to doing it What is the disease in which they used to give you an iron lung if it hit your lungs? Polio. We were that close to eradicating polio worldwide. And then someone spread a rumor in like one of the last few countries that the people coming with the vaccine would make them sterile. And so they got really angry at the UN people who were there, and they refused to get vaccinated, and then polio escaped those countries, and now it's worldwide again. We came very close to doing it. We just need to try again. Okay, we were here last day?
No.
We were, no?
Yeah.
We were here.
We were at artificial selection. Yeah.
There, with pigeons, and you saw Bert. And Bert did the pigeon dance. Pigeon. Famously, Darwin loved breeding pigeons. Breeding pigeons used to be a big thing. Some types of pigeons got so popular we don't have them anymore because we sent them away in so many places we didn't end up with enough breeding pairs. The pigeon that was the homing pigeon, the best version of that, famously has died out because everybody wanted one and then nobody bred them. The wild rock dove is the pigeon in the same way the wolf is the dog. That's what started, and people just bred it into different types of pigeons. It is a famous example of all the different ways that humans can completely mess up a creature to do whatever it is that we want it to do. You do need to find something in there that fits. Evolution can't work with nothing. There has to be a trait already present. So for dogs, you want a dog on your farm that herds animals. That's great. Lots of dogs have a maternal instinct and will herd their puppies around. Select for that trait and breed that to a level times 1,000. Boom, you have a dog that wants to herd everything, and now you can train it to herd the things you want to. If you've ever had a healer or any of those typical dogs that would, sheepdogs that would herd things, you'll notice that if you haven't trained it, it will start to train you. You go for a walk, and it will try and keep you all together. You identify traits you want. You say, these are the animals that you want to breed. You like red pigeons as opposed to blue ones. You only let the red ones breed together, and eventually you eliminate the other ones. So, first generation, second generation, third generation. Working backwards, which is the one that they bred in the first generation? Which are the two darkest? We have 1, 2, 3, 4, 5. Ooh, that's supposed to be a 3. 3 and 4. Those look the darkest. So they probably said, oh, I like those. And then those ones were supper. They didn't get to lay eggs. They had a bunch of progeny. Which ones did they breed from there?
Was this just a bunch of incest?
Second big ones.
Second and fifth look good. Because also notice they all have tall necks. So that one, and they bred together. All the other ones were eliminated. And gradually you just start to change the creature itself.
Mr. Nico,
Yep.
when they bred pigeons, is this like, there were a lot of incest?
Well, we are breeding brothers and sisters together. Yeah, that's animal breeding. You take the animals with the traits you want, and the traits you want might be only in one family. Now, every breeder knows that if you breed brothers and sisters together, you'll get, these really recessive traits that come together, like we discussed. Right? But why is that not a problem?
Because that's the trait they want.
Well, they want a trait, but what if they come together and they have, I don't know, this really bad recessive disease so they can't grow arms or something and they're a horse? Like, why is that not necessarily a problem to the breeder? What happens to those children?
Kill them?
Yeah, you just kill them.
But why does it affect humans and not animals as much?
Isn't that like
Oh, it affects the animals. We just don't care about it. So like if a human is born with no arms, we shouldn't kill them. It's not bad to be born. But if you're a breeder and you're like, oh, I like this trait in this horse, and so I'm going to take the offspring, oh, that male and that female both have the trait and I made it together. They have like 8 kids, colts, running around. And you're like, oh, 3 of them look really sickly. And I just kill them.
But is that why pigs or pugs can't breed?
That's why what?
Bad breeding?
Which ones?
Pugs?
Pugs are an example. A lot of our dog species are really inbred, so that can be a problem. But there's a whole different point of pugs. If we kept breeding, you can imagine, we bred for darker color, but what if we were also just breeding for longer necks? And we just kept selecting the longest necks. You could eventually get a pigeon with like super long necks. What kind of problems might that have for a pigeon?
Super long necks.
A super long neck?
Might be too long.
Neck big.
Yeah. I mean, it might be too long. You might have neck problems later on in life. It might not be able to peck properly. Imagine a super long neck, it goes down to peck and it goes BAM! And like it stays there for 5 minutes trying to lift its head back up. I used to feed it a certain way now because the medics do. Is it adapted for its like tasks for daily life?
No.
No, it's adapted for what the humans want. That might not be well adapted for its environment because you are now part of its environment and you're picking what survives. These ones might be really good at eating food, and that one is just good at having a long neck. And so pugs have been
What's
weaned.
like the breed that can't breed?
Oh, there's enough. I think pug might be it too. Where is there? It is.
Isn't that like the bulldog?
Let me. Did I not already show this? Actually,
Is it,
1 second.
no, I'm a pony. Oh, stop. I don't have so many.
That was Rainbow Dash. Did I not already show this? Breeding of different types over the ages? Nobody's answering.
No.
Mm,
Exactly.
I swear, I already showed this. What is going on?
I
You're
have
saying no to Liam Baker's cool haircut.
To what?
it's a cool
Liam
haircut.
Baker's cool haircut.
Hair.
Yeah,
I
no.
don't have a hair.
That just looks good. You're killing it, man.
Ahem. I would, if you are waiting, please wait quietly or quietly chat. I don't want to have to feel like I need to listen to everything you're saying because you were saying things that shouldn't be said.
Like it's almost. Oh my god.
The train station.
There was some houses on Mr. Clark Road.
Oh.
Mr. Clark. Was that one? Did you guys all see those?
What?
Oh, no, I was just telling you all.
Wait, do the junior girls have this?
Okay,
No.
We're cool.
Most of it was just.
I interrupt your conversations. I had to go back to the problems with dog breeding. This first one, one of the problems is that if we like the really pushed back face, you end up breeding, you can notice a complete lack of eye socket. And so one of the problems is a prolapsed eyeball, where the eyeball literally pops out of its socket and you have to push it back in. That is not a problem that is that came about because of the dog. That came about because humans bred the skull not to have proper eye sockets because they liked the look of the head. Other ones, we want to look what has happened historically. We have, I believe that's a pit bull, and that has affected their nasal passages. That's the original pit bull, and then we've moved it to here.
Why did we
And
Why did we do that?
and the answer is, people who buy purebred dogs buy it for the look. And one of the things they're looking for is what they call conformation. And conformation is that a breed is defined by certain characteristics. So one of the things that defined a German Shepherd was a low slope to its hind legs. It made it look fast and mean. And so we bred German Shepherds from this, which I think was like in the 40s and 30s, to this. And that is only that's a short number of generations, but this is now what a German Shepherd is supposed to look like. If you have a German Shepherd, you will famously know that they have hip problems. They have hip problems not because there was something wrong with the wolf they are descended from, it's because humans made them look like that. We also have the classic British Bulldog. Now we have one with such thick folds that sometimes they can't see because the folds get in the way of their eyes. Because they liked the folds. It was cute. Does this one have a lot of folds? No. It had a little bit. It was like a little bit of spice. It just had a tiny little bit, made the dog a little bit more interesting, a little different from other dogs. And now it's really emphasized because to really show this is a British Bulldog they bred, gotta have more folds. So the breeders are looking for characteristics that define the breed. And if that characteristic gets exaggerated over time, then eventually that tends to cause health problems because any trait exaggerated, unless it's for a very good reason, in terms of survival, is probably going to interfere with its survival. And then we have
What were they trying to do with the pit bull? Because like
having a slight slope like this is a characteristic just of pit bulls. Like that's what they have. Now it was very slight in the beginning, and then they just exaggerated it. And now we have the pug. That's the original pug, 1880, and that is nothing like what you see today. And it just looks like a regular dog. And this one, there's almost the nose is like cut off.
Can you breed it back?
There's a movement to either through encourage or force through legislation breeders to start breeding back some of the traits and say you can't go outside this range because it would be easier on the dogs.
Can you like
Yeah, I agree.
unevolve a creature?
Yeah, you just have to change what you're selecting for.
So like we go back to Neanderthals.
I mean, yeah, there's no forward in evolution. It would just be different traits. Do we have the traits that could eventually become exactly that? No idea. Sometimes if you lose a trait, you lose it forever. For example, the panda's thumb. Pandas have thumbs because they need to eat bamboo. But pandas actually don't have thumbs. Bears, which pandas are descended from, lose their thumbs as a process of evolution in making their paw. That thumb and some of the bones are actually just evolved away. They're gone. So when pandas went from a meat-eating omnivorous diet in whatever common ancestor they had to just eating a ton of bamboo every day, because bamboo is terrible food. There's not as much nutrients in it, so you need to eat a lot of it. They have to be able to grab the bamboo, but they don't have a thumb anymore. So they took a completely different bone and re-evolved the thumb. It couldn't go backwards because it actually had lost the previous characteristics. It was just gone. So there's no way to get it back. But it did re-evolve one, but it comes from different bones. It's not a true thumb. It's a pseudo thumb. So could we go to Neanderthals? Sure, but it's not like Neanderthals were necessarily worse than us. We have relatively little idea of the intellectual capabilities of a Neanderthal. They had brains larger than ours, but not larger, like when we look at a species, we look not at just the size. Whales have bigger brains than us because they're big. So we look at wrinkles, we look at body size to brain ratio. Einstein famously had a smaller brain to body size ratio than other people. It's not just the size of the brain, so you can only look at averages, not in any specific group. But Neanderthal brains are reasonably big. The only reason we look at them differently is that when we look at their tool use didn't change for hundreds of years, whereas early Homo sapiens changed fast. We seem to be innovative. But they also might have had a social structure that resisted change, and there's all sorts of stuff we don't know about that. If you look at the difference in history, you would say, oh, look, there's rapid change in, I don't know, castle design. They must be innovating a ton. And if we look over here in Asia, there is no change in castle design, and they're made of wood. Who would do that? Obviously, these are more innovative thinkers. Yeah, completely wrong. The difference is not a unified country, less social structure, and far less centralized government. Centralized government says, you guys are only allowed to build wood castles so that I can burn you to the ground if you rebel. They were told to, so they weren't allowed to. There was no difference between the two and anything else, other than one had a centralized government and the other one didn't. So we don't know about Neanderthals. We just know that, like, oh, their flakes from their arrow making didn't change as often as Homo sapiens. We don't know the reason why. Brain-wise, they easily could be just as intelligent as we are. They might have been smarter. They had bigger bodies on average than we are because they were adapted to cold climates, and they were much stronger on average than we are. Stronger animals tend to have slightly larger brains just to control more muscles, but so we can't really say anything for sure. I wouldn't automatically assume if I met one that they are going to be classic cavemen like you see in comics. They might be anything from interestingly to frighteningly intelligent. Artificial selection. So as we've discussed, it's the process, instead of nature choosing things, we choose the things. Corn is such a great example. The original corn plant has like 5 kernels. It's like nothing. Aiden, head up. Gotta wake up. Are you rowing? Are you a rower?
You are.
Well then, what? He says you are. Well, I know that early morning rows can be, especially as we're approaching a regatta. But
There was a morning row this morning.
and we took those 5 kernels, and we and the indigenous in the area. They weren't even necessarily doing like farms, but they were taking plants in an area that had plants. They were ensuring that some of the seeds were left, and they were ensuring that the seeds that were left were of plants they liked, and they wanted to make sure that they left more offspring. So all of a sudden, humans are interfering with its evolution, and we're saying we like these ones better. We're going to make sure that they leave seeds. And now the corn plant very rapidly changes form. And today's corn is unrecognizable compared to the old corn. It is hugely better for nutrition. We are at the point now in human nutrition and breeding that in the last 5 years, zoos have universally noted that they can't feed their animals fruit anymore in the way that they used to. So they used to give a ton of fresh fruit to all the animals that ate fresh fruit, and they can't now.
Why?
Can you guess why?
GMO.
No, GMO's no big deal.
Maybe because they don't like fruit.
No, they love the fruit. For the same reasons we do.
They make
It's
them
expensive.
fat.
Making them fat and giving them diabetes. We've bred so much sugar into the fruit, it's now candy. And so they have to increase the amount of like cucumber and leafy plants that don't have sugar in them, because just pure fresh fruit was starting to become unhealthy if that was the main source of their diet. There's a high amount of sugar in fruit. And famously, humans go a step further. We take the fruit, we extract the sugar out of it, put it into a gel, fill it with even more sugar, add an artificial flavoring, call it candy, doesn't have any of the vitamin C the original one does, and we say, you should eat that instead. We love candy. We evolved did anybody know why we evolved to eat candy? Like,
Because we needed lots and lots of sugar to survive.
Didn't we take
Yeah.
out all the good stuff out of like sugar? And
Yeah.
then just put all the bad stuff?
well, there's no, I mean, it's not that there's bad stuff that we put in, it's just that the lack of good stuff is bad. And we need a ton of sugar to survive. Like, we need a lot of calories per day. And if you have to, like, hunt a gazelle for your calories, that's a lot of work. And so, gathering berries gives you some sugar. A little less work, still a lot of work. And then, to make you do the work, you evolved to go, I really want sugar. So you'll spend hours gathering the fruit necessary. But now you don't have to gather the fruit. You go up to Thrifty's, pay them $2, and you get some candy. And you can eat all of it and then spend another couple bucks and eat even more candy, and there's no work involved. You have it, your tongue thinks that sugar is rare. And we live in an environment where it's plentiful because we like it and we made our environment. So we have made it harder for ourselves because we have just responded to what evolution told us was good. It's now maladaptive. In a sense. I mean, as long as you live long to reproduce, evolution doesn't really care. So it might be that we will always like sugar. It's not like it's going to get rid of it if it just gives you cancer when you're old. Artificial selection is similar to natural. There are differences in survival and reproduction. Alleles are still going to change frequency. Some alleles are going to become more common, the tall neck, the black-haired pigeon, and change in color, and you'll get a change in the population. The only real difference is instead of it being nature, it's a very specific part of nature called humans. Just so you know, the part in which humans apply this to other humans is called eugenics. And if anybody starts talking about it, they are almost always wrong, and it probably involves Nazis at some point. So just really take a good hard look at their argument, because the last time that happened, a lot of other bad things happened. So we're fairly suspicious of people that want to breed people based on characteristics. The Nazis were famously for it. The Nazis also didn't really believe in evolution as evolution, but they certainly believed in treating humans like livestock and doing this process. They had some other weird ideas about it. Eugenics is not necessarily something you should be a little bit suspicious of. There are ways, however, we are applying it to ourselves. We more and more can test our unborn offspring to see, do you have any genetic diseases? And then you can make a choice. Do I allow this unborn offspring to come to term? I know that this fetus inside of me has condition X, Y, or Z, and as the person who has the organism inside of them, you now have a choice. And people do exercise their choices. That will affect gene frequency in a population. Is it enough to direct in any amount of evolution is yet to be seen. But that would be a more natural form. It wouldn't quite be eugenics. Nobody's applying it to someone else, but you are applying it to yourself. Families have long taken a look, particularly in areas where there's arranged marriages, where they go, that families, we like the way they look. They have characteristics we like. We have children that we think would match well. It could be money involved, but sometimes it's also we want certain types of children. And so they will arrange the marriage. I know someone I went to university with that was in an arranged marriage. And he had to go back to his home country to get married. And we were all like, that's a little weird. Why are you doing that? And he was like, dating's a lot of work. I really trust my parents. They've always made good choices for me. I know that they have met the person. They're probably going to be someone that I can actually learn to live with and be fine with. And so actually it just took a lot of stress off. I'm like, I'd never thought about it that way before. I still find it a little weird, but he was doing it by choice. It wasn't like it was a forced arranged marriage. It was just an arranged marriage. He was going to school at UBC. They're both from the same original country. I won't mention which one it was. And she was going to school in the UK. So they're both going into school in different areas. And then they were to get married. And then they were to start up a practice together because they both were going to become doctors.
And then?
Don't know. Lost track after university. I deleted Facebook when I started arguing with my relatives. You know how I said I go on TikTok and I argued with people? I don't know if you noticed, but sometimes your relatives say things that make you angry. And then I realized, why am I arguing with my uncle? He's an idiot. And I just deleted Facebook like, I don't know, 30 years ago. I have no idea what anybody's doing. Animal breeding. Where are we at? Ooh, 12. Oh, is that 59?
Yeah.
Okay. We'll finish it off. I was going to do something else. But we've actually done enough. Next day, bring your lab with you. You are going to do something with your lab book, and you're going to have a write-up on a discussion with it, and you're going to use the stuff from there. What is what? Goats? Where do you see goats?
What's dope?
Dogs?
That does not say that.
It says
Put
dogs!
that into the thing and see what it thinks we.
Oh, it certainly doesn't say Doge, I'll tell you that. Dogs.
No, you gotta put it into just the purple part. That is not dog.
Okay. You don't. I will accept your challenge.
It does not think that says dogs. There's no chance.
It was the top result. It was top result. Top result.
It was not
Also, the
your
program knows not just what it looks like, but it remembers in what order and how I formed the letters, and that gives it a lot more information than you have when you're just looking at it. Thank you. It was a day of notes, but we've done enough that we're going to do discussion and reflection of that and your lab. How many of you will be here on Friday?
I hope so. I will tell my
Jamie?
French. I'm going to tell my French teacher that I'm really behind in science.
I need you to be here.
But, yeah, I will really try.
You. Oh dear. And we weren't even streaming the notes. But that's annoying. Because I turned it off for different reasons. Well, I should at least quickly display the notes. Did I already shut that down though? Let's pull that up again. Okay. Oh, then. Ugh. So we did up to here? No, we didn't do. We had done this, and then we were up to here. We had started this last day. We did the rest of the notes. I did a lot of talking. We talked about the pigeon breeding. We went over how humans have really hurt the health of animals through their breeding programs. I probably let through a few biases of how I feel about some of those, as we saw different dogs in different stages before and after. So the German Shepherd, relatively sloping back end, but not a huge amount to modern day. No wonder they have hip problems. We talked about artificial selection, humans selecting desirable traits in plants and animals by selective breeding, in which organisms breed together. It's differences in survival and reproduction that creates changes in the allele frequency. Those alleles become more common in the population over time, causing the change in the population itself. And really, it's just in addition to the natural environment, or the non-human environment, we have added humans into the equation. Humans are no different than nature. In fact, we're part of nature. Animal breeding, domesticated, and I don't think I got as far as saying this, means that we have bred it for humans. It doesn't mean it's tame. When it's tame, it means it's domesticated and trained. You can tame a wild animal, but if it's not domesticated, it's still dangerous because it will not have bred away any really dangerous instincts. Even then, I wouldn't trust an animal necessarily. A large bull is a lot safer than a wild auroch or any of those animals before they'd ever been domesticated. But they still have horns, and they could still flip their head and hurt you quite badly. We've been domesticating things for a long time. Farmers have taken the animals they liked the products of, and you can certainly see that from the gray wolf and common ancestor to all of the rest of the weird dogs. And we're going to save that.